If the positive integer x is a multiple of 8 and the positive integer y is a multiple of 18, then xy must be divisible by which of the following numbers? If a number is divisible by some factor and another integer is divisible by some other factor, the product of those integers, that is x and y, must be divisible by the product of the two factors or divisors. So, we know that x is divisible by 8. That is to say, x equals 2 cubed times some integer. And correspondingly, y is a multiple of 18, or it is 2 times 3 squared multiplied by some integer. Since xy must be divisible by the product of the two factors, it follows that xy must be divisible by 2 up to 4 times 3 squared times some other integer, which might be 1 actually. So we see that the minimum factors that xy must possess are these here. 6 is actually 2 times 3. It can be formed with the factors we find here. 1, 2, and 1, 3 make up for a 6. So we can divide xy by 6 confidently because the quotient will be another integer. 16 is 2 up to 4, which is contained here. So when we divide xy by 16, we can be sure that the quotient will be another integer. So the product must be divisible by 1 and 2. What about 3? 56 can be factored as the product of 8 times 7, that is 2 up to 3 times 7. If we divide xy by 56, what will happen? We can cancel 2 cubed with 2 up to 4. But what about 7? Can we cancel it? We would only cancel this factor here if this integer was divisible by 7. But if this integer is any other integer not divisible by 7, then the product xy will not be divisible by 56. So you can say that it is possible, perhaps xy could be divisible by 56, but we are not sure, we are not certain about it. So we need to discard this because we are looking for those divisors that must divide xy, not perhaps, certainly. So 1 and 2 only is the correct answer choice.